Hello dear students, this is our third lesson of quadratics. In the first two lessons, we have so far learned about the graph, two different cases and the graph of the quadratic expressions, and then in the second lesson, we solved a linear and quadratic equation simultaneously and understood what was basically the graphical interpretation of the solution. And we further discussed three cases. In the first case, the line intersects the quadratic polynomial graph at two different points. In the second case, it is tangent to that quadratic expression, and in third case, there is no common point. We also learned about the vertex of the parabola in both the cases. Today, we are going to learn 5 different cases in which we convert any quadratic expression into standard form. Y is equal to x square. You can easily say its minimum value is 0 at x is equal to 0. Y is equal to x square minus 2. You can see its minimum value is minus 2 at x is equal to 0. Y is equal to 2 minus x square. You can see its maximum value is 2 at x is equal to 0. Now we are going to learn that how to get the minimum value, maximum value or vertex of a quadratic expression. There are 5 different cases. In case 1, coefficient of x square is plus 1, like this. In this case, we will convert the expression into this form: x plus something whole square plus any constant. Let us learn this. X square minus 16x, we will write equal to x square minus 16x. We will take half of b, which is minus 8, and we will add and subtract the square of minus 8. By doing so, we first 3 terms will give us a complete square of, which is x minus 8 square, and next is minus 64. We have converted this into this form. Its minimum value is minus 64, and which is at x is equal to 8, not at x is equal to 0. So 8 minus 64 is its vertex. Another example of same case, x square plus 4x plus 8. What we will do? We will take half of b, which is plus 2. We will add and subtract its square to make it a complete square. Plus 8 will be at the end. This is x plus 2 whole square now, and minus 4 plus 8 is 4. So its vertex is at minus 2, 4. And since coefficient of x square is positive, this 4 is its minimum value. This was case 1 when a was positive and was equal to 1. Let us move to our second case now. Again, a is positive over here, but it is not 1. It is 2, 3, any other number. In this case, what we will do, we will take the coefficient of x square common in the first 2 terms. Constant will be written as it was. Now, we will complete the square by performing the same operation within the brackets. We will write x square minus 66x. What is half of minus 6? It is minus 3. We will add and subtract the square of minus 3. Now, first 3 terms will again complete the square, which is x minus 3 square, and next will be minus 9. And by doing so, we will ultimately get 2 times x minus 3 whole square minus 18 plus 19, which will be 2 times x minus 3 whole square minus plus 1. So what is the vertex then? It is at x is equal to 3 and its value will be 1. So minimum value of the quadratic expression will be 1 at x is equal to 3. Second example of same sort, now coefficient is positive but it is plus 3. We will take 3 common in the from the first two terms, x square minus 4x we will get. Now half of coefficient of x is minus 2. We will add and subtract the square of minus 2. First three terms will again complete the square. This will give us 3 times x minus 2 square. This minus 2 square is 4. So this will be 3 times x minus 2 whole square minus 13. So what will be the vertex? 2 and 13. So students, up to till now we have learned the two cases. In both the cases A is positive. In case 1 A was 1 and in case 2 A was any positive number other than 1. Let us move to our third case now. In the third case, A will be a number which will be negative number. In third case, A will be minus 1. Like over here. What we will do over here, we will take half of this coefficient, which is 2. Its square will be added and subtracted. First we will add square of 2, then we will subtract square of 2 plus 4x minus x square. First term will be written as it is and minus negative 1 will be taken common out of the next 3 terms and we will get x square minus 4x plus 4. And this is a complete square of x minus 2. For x is equal to 2, we will get 4. But in this case, this 4 is not the minimum value. This is maximum value because coefficient of x square is negative. Parabola will be open downward. So vertex will give us its maximum value. So 2, 4 is its maximum value. Second example of same case. Now half of coefficient of x is 4. Its square will be added and subtracted. What we will get? We will get 16 minus 16 plus 8x minus x square and this will give us 16 minus 1 will be common, x square minus 8x plus 16. Last 3 terms in this case will complete the square of x minus 4. So vertex will be 4, 16. When x is 4, y is 16 and you can understand now the value 16 is the maximum value. In the fourth case, A is again negative but it is any other number except minus 1. So in that case, what we will do? We will take the coefficient of x common in the last 2 terms and now complete the square within the bracket. This will give us x square minus 4x minus 4's half is minus 2. Its square will be added and subtracted. By doing so, we will get 7 minus 2. First 3 terms will complete the square of x minus 2. This is minus 4, this minus 2 plus 8 and we will get 15 minus 2 times x minus 2 whole square. So its vertex will be 215. Second example of same case, it is minus 2. I will take this is equal to 13 minus 2 times x square minus 4x. Half of coefficient of x is now minus 2. Square of minus 2 will be added and subtracted. First three terms will complete the square, which is x minus 2 square, and then we will get 8. This will be 21 minus 2 times x minus 2 whole square. 2 and 21 is the vertex now. So its maximum value will be 21. So we have gone through the fourth case, in which coefficient was negative, but it was any number other than minus 1. The last case is important. Coefficient of x is itself a square number. Like in this question, it is 9, which is square of 3. So in this case, we will write this as 3x whole square. And this 3x will be taken out of this, 2 and 3x. Now what is half of this coefficient? Minus 1. Its square will be added and subtracted. We will get 9x square minus 6x plus 1 and minus 4. This is 3x minus 1 whole square minus 4. Its minimum value now, because coefficient of x square is positive, its minimum value will be at x is equal to 1 by 3, and that will be minus 4. Last example of today's lesson, it is 25x square, which is 5x whole square. We will take 2 into 5x. 5 and 2, 10. We are left with, this is 8 into 5x plus 4. Half of 8 is 4. 4 square will be added and subtracted. I will rearrange this 25x square plus 40x plus 16 minus 12. This is 5x plus 4 whole square minus 12. So its minimum value will be at minus 4 over 5, and that will be minus 12. So in today's lesson, we have learned how to transform any quadratic expression into standard form, which would enable us to identify the vertex rapidly. Dear student, up till now we have learned about the graph of a quadratic expression, finding its vertex, solution of a linear and quadratic equation, and the three cases that a linear equation or line can intersect the quadratic graph, or it can be a tangent to that graph, or it can have no common point. And today we have learned about 5 different cases in which we converted a quadratic expression into standard form to get its vertex rapidly. In next lesson, lesson number 4, we will learn about the solution of quadratic inequality, which will be linked to our lesson number 1 of the quadratic inequality. Thanks for watching. I am very hopeful that this lesson would be very beneficial for you. Please subscribe my channel so that you are timely intimated about our upcoming new videos. Stay tuned. Allah Hafiz.